Hi everyone and welcome back to my channel in Economist. So in the previous video, we have started off our discussion on Logit model and Probit models, right? So we have started off with the concept of limited dependent variable models, right? So we have said that the dependent variable can take only two values or only a few values. Discretely many values can be taken by the dependent variable, and in that scenario only, the model will be known as the limited dependent variable model. If you haven't watched this video, please check that out first because that is the absolute foundation. Before going to Logit and Probit models, you have to understand what is limited dependent variable model and what are the limitations, right? So we have discussed this in our previous video. So I'm just taking you through what we have done and then we'll enter into today's video, right? So this is the concept which we have done, and then we have understood this with the help of an example. I have given you the house owning example, house ownership example, where I have said that the dependent variable takes the value 1 if the person owns a house, it takes the value 0 otherwise, if the person does not own the house. And then how do you formulate the model? Right? So this is the formulation. The final formulation was like this. The conditional expectation of the dependent variable, basically yi given xi, is exactly equals to the probability pi, and it is in a linear fashion. If this probability is related in a linear fashion with the explanatory variable xi, that is why it is known as the linear probability model, right? So this we have done, and then we have discussed what are the basic limitations of this model. So there are two basic limitations which we have also, done in our previous class. And then in order to solve this problem, in order to solve the problem which is associated with linear characterization, we have said we have to go into non-linear probability models. One such model is the Logit model, where the probability, instead of being linear, the probability is something like this, right? So this is the characterization of the Logit model, which we have again done in the previous video, if you remember. This is the place where we have stopped. This is the linearization process. And observe here if you see yi, the dependent variable yi and the probability pi is not, equivalent. Yi cannot be expressed only in terms of pi. So this entire thing is yi. This entire thing is basically the yi. So I have, stopped at this place, that probability is not only a function of xi. So see here, probability is not a linear function of xi. Log odds ratio is a linear function of xi. So that is the place where we have stopped our discussion. And this is the non-linear character. This is the odds in favor, odds against of owning a house. This we have discussed. So we have stopped at this place, which is a non-linear characterization of probability that we do using Logit model, right? So today we will go a little forward and we will understand what is the estimation process. We have understood the basic characterization of the model. So we'll go into the estimation process of Logit model, and we will understand why OLS is not suitable for Logit model. So understand this, that we cannot use the OLS estimation in Logit model because of some fundamental differences between linear regression and logistic regression. So if you remember, in order to apply OLS into the linear regression, we have to satisfy some of the assumptions. Different assumptions are there that we have, extensively discussed in our classical linear regression model videos. If you haven't watched that, again, I'll give the link in the description. Please check that out. So linear regression has to satisfy some of the assumptions for being, permitted to be called as classical linear regression model, and that can be estimated using OLS basically, right? So here we will see Logit model violates some of the assumptions. That is why OLS is not applicable here. So see here, what could be the violations? First is the nature of the dependent variable. I have listed all the, violations here. Why Logit model, violates the OLS, classical linear regression model assumption, and why OLS method is not applicable. So the first point would be the nature of the dependent variable. In Logit model, as we have seen, the dependent variable is still binary. It can take value 0, 1 like that. Only some discretely many values can be taken by the dependent variable. But in order to apply OLS, you need a continuous dependent variable. As you know, till now we have discussed all the, discussion using the continuous dependent variable only. And that is an essential condition for OLS to be applicable. Applying it to binary outcome will violate one of the core assumptions of OLS, that the dependent variable has to be continuous. Both the dependent and independent variable, till now we have assumed them to be continuous. But now, if you are in the purview of limited dependent variable model, then this, dependent variable will become binary, and hence we will violate this assumption of continuity. So this is the first point. Second point would be predicted values can be out of bounds. This we have, discussed in our previous video, that the predicted probabilities can be less than zero, or it can be greater than one, which will violate the natural rule for probability, that probability should be in between zero and one, both inclusive. So the predicted values can be less than zero, greater than one, which makes no sense for probabilities. Logistic regression uses logistic function. This also we have seen the general characterization of that, which ensures that the probabilities will be in between 0 and 1. That is why we need to go into some other methods. The third point will be the violation of homoscedasticity. When the dependent variable is binary in nature, or it is, discrete, it can take only discretely many values, it is categorical in nature, then this assumption of homoscedasticity is also violated. The variance will take this particular form, which purely depends on the value of x, and it will again lead to heteroscedasticity. If heteroscedasticity is present, then the OLS assumption will again be violated. This is third point. The fourth point, this also we have discussed in the previous video, the error term is not normal now. It will be a discrete distribution. OLS assumes that the error terms has to be normally distributed, but in case of Logit model, errors are not normally distributed, and hence again we cannot use OLS. So underlying model assumes that the logistic distribution of a latent variable, right? So this is the fourth problem, and the final problem will be inefficiency and the bias. That OLS estimates in the binary models are biased and inconsistent. So if you have the Logit characterization and still you are applying the OLS method for estimation, this will give you biased and inconsistent estimates, especially for small and moderate sample sizes. That is why in case of logistic regression, we take the help of maximum likelihood estimation. That is what we will discuss in this video. How do you use maximum likelihood estimator in order to estimate the logistic regression model, which is a more efficient and more consistent way in case of presence of binary outcome variables, right? So this much I hope is absolutely clear. What are the reasons? What are the reasons that we need to go beyond OLS and we need to apply some other methods? Specifically, we have to apply the maximum likelihood estimation method in the presence of logistic regression model. Okay, so now let us directly go into the method of maximum likelihood estimation and see how we could use it for our advantage, for the estimation of parameters in case of Logit model, right? So in case of maximum likelihood estimation method, as you know, we have to form something called the likelihood function. We form something called the likelihood function. This, I hope you have done this before. In case of mathematics also, you do this method. So likelihood function, what is this likelihood function? Likelihood function is a function of all the set of parameters given all the observed observations. So this is basically the general form. Likelihood will be a function of all the parameters. So where theta will be the set of all parameters, that you have in the model. So in our model parameter, so in case of our model, it will be basically alpha and beta, slope parameter and intercept parameter. Set of all the parameters that you have, and here you have all the observed observation. So suppose you have n responses, independent responses. Suppose y1, y2, y3 up to yn. These are the sample. These are the sample consisting of n independent responses. What are the responses? Responses could be you are owning a house or not. So we are continuing with the same example that I have shown you. House ownership problem. So if y takes the value 1, it means you own a house. If y takes the value 0, it means you do not own a house. So if y1 takes the value 1, it means the first person that we are asking, that are who is under this survey. If y1 equals to 1, it means the first person owns a house. If it is 0, it means he does not own a house. And similarly, you will survey all the n individuals, and in this process you will get n different responses, and each of the responses are independent of each other. We assume all the responses are independent of each other. This is an important assumption because that will help us to formulate this likelihood function. So suppose you have this n members, n responses. Now, if you have that, what will be the likelihood function then? The likelihood function will be simply the probability of y1, y2, y3 up to yn. And this can also be written probability y1 into probability y2 into probability yn. So joint probabilities can be written as product of individual probabilities when the responses are independent. When each of the, that is why I have emphasized on this, that this independence assumption is important. So this is the likelihood function that you have, and you can break it down into these two, into this product format basically. Probability of y1, y2, probability of yn. Now, what we will do, we will again make some assumptions. Suppose you arrange, the sample, you arrange the sample in such a way that the first n1 observations or say first n1 individuals, say first n1 individuals owns a house, and the next n2 individuals do not own a house. So altogether you have n number of people. See here you have n different observations, n different responses. So you have altogether you have n different individuals. So n1 plus n2 has to be equals to n. Right? So you arrange your sample in such a way that the first n1 individuals owns a house, and for the next n2 observations, for next n2 individuals, they do not own a house. Then how will you write your likelihood function? That is the question. The likelihood function will be simply, so this much we have seen earlier, probability y1, y2 up to probability yn. And this is important. How do you further write it? You can break it like this. P1, P2 up to Pn1. These probabilities you will separate out. And then for the next term, it will be 1 minus probability n1 plus 1. Observe this, that for the n plus 1th individual, the person does not own a car, right? From n plus 1, n plus 2 up to n observation, the probability will be 1 minus probability n plus 1. n1 plus 1, 1 minus, then it will be n1 plus 2, all the way up to 1 minus probability of n. So please try to understand this step, what I have done. So for first n1 observations, there is a positive probability because see, n1 individuals owns the house. So how do you denote that? This is the way you denote that. P1, P2 up to Pn1. And after that, for n1 plus 1th observation, from that individual to nth individual, those people do not own any house. That is why you will take 1 minus of that probability. P is the probability of owning a house basically, right? So 1 minus Pn plus n1 plus 1, 1 minus Pn1 plus 2, so on and so forth up to Pn 1 minus Pn, right? So this will be the step, and then what you can do, you can write it in a compact format. I from say 1 to n1, you can write it to be Pi, and for the next portion, you can write I from n1 plus 1 to n. This will be 1 minus Pi. And again, if you have to write it in a more compact format, you can write it in this way. Say this, I write I from 1 to n. This will be Pi to the power yi, and 1 minus Pi to the power 1 minus yi, where this yi takes the value 1, for first n1 observations, and it takes the value 0 for next n2 observations. Right? So this is the way you will form the likelihood function. This is the likelihood function that we need to formulate firstly. So see, if you put y equals to 1, yi equals to 1, what you will get? Pi to the power 1, 1 minus pi to the power 0. So this will be 1, it will be only this much. Only the first observations will stay. You will get only this much. And if you put 0 here, only the last observations will stay. So this is the likelihood function that you will get from this exercise, right? So in case of Logit model, this is the likelihood function that you will get. And now once you have the likelihood function, what you have to do, you have to maximize the likelihood function. So firstly, okay, so firstly we'll take the logs and then we'll try to maximize. So log likelihood will be what? Simply take the logs on both sides. So here in this function, you have to take logs. So it will be log L. And here you have the product. If you take the logs, it will be sum. Sum over I from 1 to n1, yi log pi plus summation I from n1 plus 1 to n, 1 minus yi, and then you will have log of 1 minus pi, right? So this is what you will get. You will get this. Please do this, on your own. Please write it down and try to understand step by step what I am doing. Because only if you watch this video, you will not understand anything. You have to write it on your own to understand what is the step by step process I am following. So this is basically a monotonic transformation. Log means a monotonic transformation of the original likelihood function. Then once you have this log likelihood, what you have to do, you have to maximize this. You have to maximize this with respect to the parameters of your model. What are the two parameters? You have alpha and beta two parameters, where this pi is simply 1 minus 1 plus e to the power minus zi. So you can write it alpha plus beta xi, right? So this is the probability. Once you maximize this, once you have the data set with you, once you maximize this, you will get alpha star, beta star. So alpha star, beta star will be the values of alpha and beta that will maximize this log likelihood function. So this alpha star, beta star, that will maximize the probability, of the observed sample, right? Of the observed sample. So this is how you find out the estimated values. Estimated values, this is basically the MLE estimates. MLE estimates of the slope parameter and the intercept parameter when you are in the context of Logit model. Right? I hope this process is absolutely clear. If you want to take a screenshot, you can do that, or you can basically pause the video and write it for yourself. That will be the best way to understand the process, right? I hope this thing is absolutely clear to you. Now we will go into the Probit model, which is a very short thing. I'll be explaining it theoretically. What is the Probit model? So in case of Probit model, the model looks something like this. The model is yi star is alpha plus beta xi plus some error term. Suppose I call it this. Suppose this is the model where what is this yi star? Where this yi star has a special name. It is known as the latent variable. It is the latent variable. You can consider this to be an unobserved variable, right? Latent variable means which is basically unobserved, which is unobserved. So you have a model like this, and the original dependent variable takes the value 1 when this yi star is strictly greater than 0, and it takes the value 0 otherwise. So again, you see, again the dependent variable is binary in nature. Dependent variable is binary in nature, and we have a latent variable which is actually unobserved, latent variable which we are using for our approach basically, right? So this is the thing. Now how do we proceed with this formulation? Now suppose we want to find out what is probability yi equals to 1. So if you use this, what you get, it directly means that yi star has to be greater than 0. Probability yi taking the value 1 means yi star is strictly greater than 0. So this you can write in turn if you use this particular expression. What you can write? You can write it will be simply it is strictly greater than alpha plus beta xi. Right? I hope this is absolutely clear. Use this thing, you will get this. Epsilon I will be strictly. So let me show you if you still have any doubts. So yi star greater than 0 means what? This entire expression alpha plus beta xi plus this is strictly greater than 0, which basically means this has to be greater than minus of alpha plus beta x. So that is what I have written here. So I'm just rewriting the expression. I'm changing the sides only, nothing else. So you'll get this. Now, can you identify what you can write this? Can you identify what you can write? This expression can be written as this. yi equals to 1. It will be simply 1 minus the CDF, the cumulative distribution function alpha plus beta xi, and it can be in turn written as CDF of alpha plus beta x, right? So this is the reduced form what you have to firstly understand. This is the mathematical thing where this f of alpha plus beta xi is the cumulative distribution function. Now the question is, what kind of cumulative distribution is this? What kind of cumulative distribution? In case of Probit model, always remember the CDF that we are talking about is always a normal CDF, normal. CDF of the normal distribution. The CDF we consider CDF of a normal distribution. So how will you write it down? It will be, so this is in the context of profit, in Probit context. Right? So basically what you will write, the probability will be here simply alpha plus beta xi, and you will write it in the form of normal CDF. So if you remember, it will be minus infinity to alpha plus beta xi and then fz into dz. Where what is this fz? 1 upon sigma root 2 pi e to the power minus zi squared upon, right? So this I hope everyone knows. I hope you know what is normal, normal distribution and standard normal distribution. If you know this, you can, get this, right? So Zi is basically, you can consider a standard normal variable. So this is the process. Now the question is, how do you estimate? How do you estimate this model? Estimation process is almost similar to Logit model, only the likelihood function will be a little different. So see, we know probability is f of alpha plus beta xi. This is what we have. So what you can do, alpha plus beta xi will then be simply f inverse of pi. It will be f inverse of pi, and once you have this, you can again write the likelihood function, or let me write the log likelihood function only. So the log likelihood, the first expression will be the same what we have derived here. So this expression will be exactly the same, only this pi will be different now. Pi and 1 minus pi, instead of pi, you will put what we have here, right? So only that much will be different. Let me write it again for you. I will be from 1 to n1. Here you have yi log of pi plus summation I from n1 plus 1 to n, 1 minus yi, and then you have log of 1 minus pi, right? Now simply replace this. It will be summation I from 1 to n1 yi log of, instead of pi, you will write f of alpha plus beta xi plus summation I from n1 plus 1 up to n, 1 minus yi log of, instead of 1 minus pi, you will write 1 minus f of alpha plus beta xi. Right? So this is the log likelihood function now. Again, you have to maximize, simply maximize this thing again with respect to alpha and beta. You have alpha, beta here, alpha, beta here. So alpha and beta are the only two parameters. You will maximize this with respect to alpha, beta, and then you will again get what will be alpha star MLE and beta star MLE, right? So this is the process in which you can estimate the profit model. So I hope you got the process. So we have started our discussion with the limited dependent variable model. We have understood why linear characterization is not, helpful. What are the different limitations? Why OLS is not applicable? Then we have gone into the estimation process of the maximum likelihood method. In case of the Logit model, how do you use the maximum likelihood method? And also in case of the Probit model, how do you go into estimation? Right? I hope you like this video. If you do, don't forget to like this video and do subscribe to this channel in Economist, and this will help me to grow my channel and also to continue making such useful videos for you. And if you have any doubts anywhere, please let me know in the comment section. I will be more than happy to address, right? So thank you so much. And this is the end of this playlist. So I hope you like this entire playlist. If you do, show your love and support, and let's meet you in some other video. Thank you so much for your time.